We are all aware that some things float while others sink. But have you ever wondered why? You may think it's because of its mass or its size. Well, you're not exactly on point with that. Let's look at this beach ball floating on water. Try applying a force pushing it downwards and you'll feel a force pushing it back upwards. It means the water is exerting an upward force on the beach ball called the upthrust or buoyancy, and the upward force is called the buoyant force. No matter how hard you push the ball, it won't sink because it is full of air, which makes the object less dense than water. The same goes with the ship. It floats because it has a hollow part filled with air, occupies more volume in water, and has a lesser density than water. Hence, the upthrust exerted by water is greater than the weight of the ship.
Now, let's get over here and check out this coin sinking. Notice how it's just small but it still sinks? It's because it's compact and solid. It occupies a lesser volume in water and has a greater density than water. Hence, the upthrust has a weaker exertion than the mass of the coin. And that also goes the same with a huge rock. It sinks for it is intensely dense. To get the buoyant force, its formula includes the density of liquid, the acceleration due to gravity, and the displaced body volume of liquid. Therefore, buoyant force is equal to density times acceleration due to gravity times volume, giving the product the SI unit N for newtons.
Archimedes' principle can be seen through our daily activities. For instance, a boat's captain casts his anchor. Then he suddenly feels the anchor lighter as it immerses into the water. Were you aware of how it is lighter below the surface of the water and was heavier above? This is because an object loses weight due to the upthrust exerted by the water. It is proven and stated by the Archimedes Principle, or also known as the law of buoyancy, that when an object is immersed in a liquid, the apparent loss of weight of an object is equal to the upthrust, and this is also equal to the weight of the liquid displaced. Let's say the anchor weighs 20 kilograms above the water, then weighs 15 kilograms below the water. Spot how the water rises as we immerse the anchor? This can be measured by the weight of the object above the water, 20 kilograms, minus the weight of the object under the water, 15 kilograms, equals to the loss of weight of the body, 5 kilograms. This loss in weight of the body is proportionate to the displaced body of water, which in this case is the rising of water. Remember that the principle of the Archimedes Principle will always be applied to any partially or fully immersed object. That's why you can float in water and feel lighter in water. So, the next time you go to the beach, try observing and attempting the Archimedes Principle. For sure you'll have fun.